Bad practice in using enterprise service bus systems. In this course you will learn what the differences are between the ESB pattern and an ESB system, what requirements for an ESB system may be derived from the SOA standards, what the problems an ESB has in the message delivery practice, the data transformation practice, the applying security protection, and how these problems have to be resolved. How to position an ESB and related team in the company to maximize benefits from the use of the ESB system. What the difference is between the SOA ESB pattern and generic ESB system. It is difficult to say which one came first, the ESB pattern or a product called an Enterprise Service Bus System, or ESB. An invention of ESB is claimed by both TIBCO and Sonic Software. Back in 2002, David Chappell of Sonic Software clearly articulated that popular message systems like Sonic MQ or IBM MQ series did lack a simple element, an integration between messaging senders and receivers on the one hand and the web service technology on the other. Before ESB products appear in the market, application service server vendors tried to integrate messaging with web services. I even remember how BEA WebLogic Application Server version 4.0 had some issues with concurrent message retrieval by the EJB message beans and an asynchronous nature of JMS. Nowadays, a generic ESB system usually includes following functionality. Web service input-output interfaces, messaging system for message delivery, semantic analysis and content-driven message routing, data transformation, refining and enriching, security policy application points, security information transformation such as encryption, decryption and digital signing, a collection of adapters and several interfaces of different types. In parallel, the ESB pattern polished its statements. This pattern came out as a blueprint declaring that services interact with each other by means of a service messaging bus. The bus was assigned the tasks of resolving A. Logic topology of service consumers and services themselves, and B. Physical mapping and topology of the service consumers' components and service endpoints. That time, it was almost obvious that if a service bus should interact with multiple different services, it must understand all message semantics of the service messages it transmits, and use an internal unified language to be independent from the private message semantics. In other words, data transformation was identified as an internal procedure only. Therefore, the ESB pattern has combined with such well-known patterns as mediator pattern, asynchronous request-response, and publisher-subscriber patterns. This was it. You see how significantly a modern ESB system extends the ESB pattern. There were some reasons for such an extension. First, practitioners found that the XML schemas used in the messages from different services were incompatible with each other. That is, the internal feature of data transformation became a must-have feature for integration between different service providers. Since an ESB system had obtained a right to work with the message content from the beginning, the next logical step was to use this content to define where the message to be delivered to. That is, to apply a content-driven message routing. In line of this logic, the developers figured out that they could not only transform the text formats in the messages, but also add and remove the content, that they can go for an additional content and put it in the messages. Thus they started to perform refining and enriching of data that consumers exchanged with the services while consumers might not even know about it. A high hype around ESB affected service security as well. I would attribute this movement to marketing rather than to security specialists, but several ESB vendors started to offer an ESB as a place where security means and measures may be applied. For example, a consumer sends a request to a service. The request reaches the ESB, where it is encrypted and sent further to the service. The service decrypts the request. Since an ESB system is external to the consumer's and service's code, it is very convenient for developers. Now security may be added to the service interactions later on. All these take place when a community of the ESB vendors is still unable to decide what an ESB system is. Is it an integration instrument or a service intermediary? Anyway, they additionally equipped the ESB system with a set of adapters for integration purposes. The latter included adapters for different packaged applications like SAP, Oracle Finance, MDM, and so on, as well as connectors for FTP, XML over HTTP, .NET, and Java protocols. The logic was simple. Consumers would figure out what an ESB system might be for, but the vendors said already, we would highly recommend it as a must-have element of SOA environment. What SOA standards require for a service intermediary? While I can consider an ESB system a service intermediary, I have to explain what I mean by SOA standards. First of all, SOA standards are produced by such standards bodies like OASIS, OMG, and the Open Group. These are the standards that address service-oriented architecture rather than parts of services. This means that the standards related to any implementation technology like web services or REST are not SOA standards. Web services or REST may be used for the purposes of a standardized integration with no regards to service orientation. Service-oriented architecture defines the actors of the service interaction. The actors are consumers, services, service providers, service owners, service stewards, service delegates, and optionally, service intermediaries. In SOA, any consumer may be a service at the same time and vice versa. Any service may have several interfaces to interact with the external world. Particular technologies used to implement SOA are irrelevant to the architecture. For example, if an architecture states that a consumer A exchanges data sets with a service B, an implementation of interfaces for this exchange may be based on web services or FTP. Requirements to a service intermediary should be extracted from the definition of service interaction. In particular, OASIS SOA standards state that before a consumer starts an interaction with a service, this consumer has to familiarize itself with the service description offered by the service provider. If business functionality and real-world effect, including service results, can satisfy the needs of the consumer, the latter might engage the service. So, a service intermediary is an actor and acts as a service to its consumers. Also, there are certain conditions beside the consumer's needs that have to be in place for a service interaction. These conditions include willingness, trust, and capabilities. So, a consumer formula is: I have a need, I trust a particular service, I want to interact with it, I can interact with it. It is another question how a consumer interacts with the service. A service intermediary is the part of the answer to this how question. Therefore, the core requirements to an intermediary are: A service intermediary, if released as an ESB, must preserve the consumer formula and consumer's vision of the service interaction. A consumer should be able to establish a trustworthy relationship with the service intermediary and preserve them in the interactions. A service intermediary should support service interaction in all successful and failing cases. A service intermediary should support service contract agreement between each consumer and service that communicates via the intermediary. If a service intermediary is not a business entity participating in the business transactions between consumers and services, that is, it is just a technical system, it should not affect business transactions. A service intermediary as a technical platform should support a convenient, for example, dynamic deployment of technical parts of interacting parties. I can offer you an exercise for homework. Try to challenge the ESB you use in your company against aforementioned core requirements and find if your use is in line with the SOA standards. What can go wrong with an ESB supporting team? Message delivery. Every ESB system has an IT team that supports it and promotes its use. This team and its activities are the subjects of an architectural and IT governance. To understand what an ESB team should and should not do, let me analyze the core SOA standard-based requirements. The first and the cornerstone consequence of SOA standards is that service consumer must know service or service provider. Without such knowledge, no business trust is possible, i.e., no interactions with business services are possible. SOA standards reflect a common trend of business ownership penetrating centralized IT organization. If it is not happening already, soon your business units will dictate IT teams if the latter may combine particular business services into new products, or if any changes to existing services are possible. Thus, no ESB system may hide consumers from services. With this regard, the only features remain with the ESB system are a message delivery and a translation of a specified logic name of service into the physical endpoint of the service interface. I have to outline that the popular role of an ESB team as a broker who makes its own decisions on who will serve a particular consumer's request is not acceptable anymore. So, all declarations of an ESB team like "give us your request and we will place it with the right service" are not compliant with SOA standards. An ESB system, as well as an ESB team, may make no decisions about who particular consumer interacts with and how. An ESB system is nothing more than a routing infrastructural element in this case. The same type of comments relates to the content-driven routing. An ESB may not decide where the message should be routed based on its content, but must deliver the message to the addressee specified by the sender. If an ESB team wants to become an aforementioned broker, it must become a business intermediary with business accountability to all its consumers and business responsibility for all interactions with the business services. Only in this case, business service consumers will set service contracts with the ESB. However, these service contracts should be about business functionality provided by business services, and the ESB will become accountable for this functionality. Have you seen any ESB in such a business capacity? I've not. If you want to learn more about the role of service contracts in service interactions, I can recommend you take 2 other courses: New Understanding of Service Contract in Service-Oriented Ecosystem, and How to Save on Cloud Security, a Gateway Service. What can go wrong with the ESB supporting team? Data transformation. The term data transformation, as well as data integration is ambiguous. Indeed, what does mean transforming 5 into anything else? What does mean integrating 17 with 21? It is senseless. In reality, data transformation is about transforming one meaning of data or value into another meaning. That is, I am talking about semantic transformation. Also, when I mention data integration, I mean mapping from one semantic system into another. When a consumer learns service description of a potentially engaged service, the consumer has to understand what the service description explains. That is, the consumer has to use the same semantics and ontologies that the service provider used when it wrote the service description. Otherwise, nothing good will come out of the service interaction that returns either something that the consumer had not requested or something which is not what the consumer thinks it is. This means that the consumer and the service must talk the same language before they interact. This fact makes an ESB system's feature of accepting a message from a consumer to a service which does not understand the message totally useless. Also, SOA standards outlaw transforming business semantic of messages without an explicit consent of the consumer and service, and this consent has to be written in the service contract. This means that an ESB team may not offer an arbitrary data transformation via an ESB that consumers and services are not aware of. Moreover, an ESB team may not refine and enrich message information on its own without an explicit permission of the consumer and service. Only consumer and service together may decide if the source of refining or enriching data is trustful enough to become a part of their business service interaction. Let me repeat, an ESB as an IT infrastructural element has nothing to say in the business service interactions. Just in case, if you're still curious who actually may speak as a consumer or service, I can say that these are the business owners of the consumers and the services code. What can go wrong with the ESB supporting team? Communication security. Finally, let's look at the security issues of an ESB system. A presence of an infrastructure router, such as an ESB system, changes neither security concerns nor security solutions applicable to services. This means that if a consumer communicates with a service directly using a secured HTTP or HTTPS, an appearance of an ESB in between them may not increase or decrease security protection of that communication. I hope you agree with me on this. Let's assume that someone is going smart and places all security protection on the ESB instead of the consumers and services. What do you think would happen with the service security? My answer is, the service security will be broken. Here is why. For instance, a consumer and service have agreed on protection of data integrity in their interactions. This means, in technical terms, that each message must be digitally signed using special algorithms. This also means that the consumer's message must be digitally signed when it leaves the consumer side, as well as the response message must be digitally signed when it leaves the service side. If the message signing is postponed and takes place when the message appears at the ESB, this violates a service contract because the messages leave the consumer and the service not signed. B, a security protection because anyone can intercept the messages between the consumer or service sides and the ESB and alter the message content, making a digital signing in the ESB meaningless. The same logic relates to message confidentiality or encryption. Security mechanisms such as message non-repudiation is also compromised if this mechanism applies to the messages only when they reach the ESB. How an ESB can prove that the message it transmitted to the service was sent by the consumer, but nobody else, if the consumer denies the fact of sending this message? Overall, an idea of moving security controls from consumer and service sides onto an ESB is totally wrong. It opens service security to the world. It is an unsecured solution. An ESB must have its security, no doubts in this. However, an ESB security should not substitute service security, regardless convenience to developers. That is, service security is a design time task that should be in the development from the day one. How to position an ESB system and its team. To overcome described bad practice of using ESB systems, I can offer the following recommendations that are proven by several years of real-world practice. Before using an ESB system in your organization, write and sign off governing policies about the usage of the ESB. Who, when, and how will use the ESB system? Who, when, and how will support it? In what business and technical cases the ESB should and should not be used. Define and reach a common agreement on the role of the ESB and related team, whether it is an infrastructure element of IT or a business unit providing intermediary services in business transactions. If the ESB is an IT infrastructure element, create a periodic control on how the ESB is used in order to prevent the ESB team from gaining an unauthorized ownership over the elements of business transactions. If you omit this prevention, sooner rather than later, the ESB team will become the major player in all service interactions and will dictate consumers and services how they have to work, and you can say goodbye to your SOA implementation if this happens. If the ESB is an IT infrastructure element, there is one of two possible cases relating to the ownership management and business transactions for the ESB. That is, in a particular service interaction, all operations offered and performed by ESB belong either to the consumer or to the service. A. If the consumer owns the ESB operations, the consumer becomes responsible in a business sense for message routing and data transformation in the service interaction. B. If the service owns the ESB operations, the service becomes responsible in a business sense for message routing and data transformation in the service interaction. In both cases, since the ESB does not appear as an independent entity in the business interactions between consumers and services, there is no need to mention it in the related service contracts. Otherwise, as I said already, the ESB must be mentioned or even become one of the participants of the service contracts with all related business duties. What you have learned in this course. An implementation of an ESB system differs from what the SOA ESP pattern defines. An ESB system and related team may play one or two roles in an enterprise. It may be an element of IT's infrastructure or an intermediary business unit. SOA standards require service consumers and services to know each other and establish trustful relationships as a precondition of service interaction. An ESB system may not prevent this, but has to provide a loose coupling technical support. Only an ESB business unit may fully decouple consumer-service relationships. If an ESB system as an infrastructure element is used, then A. Its operations must be owned by a consumer or service for each individual service interaction. B. Only consumer and service may decide on any data transformation for outgoing and incoming messages, including data refining and enriching. C. Only consumer defines which service it sends messages to, that is, which service should serve this consumer. D. Application of service security protection may not be replaced by applying this protection in the ESB only, otherwise it breaks the service security protection. The use of ESB in an organization should be strictly governed and controlled to prevent the ESB team from taking control over all service interactions and dictating to consumers and services how they have to work. Please allow me to thank you for your time and attention. I hope you have found useful information in the course. If you have any related questions, please post them in the related forum on the same website, and I will do my best to respond as soon as I can. Also, you are very welcome to post your opinion and considerations about the course in the same forum. If you have a consulting proposal with regard to this or another course or the blog post, please use Contact Me instant messaging on the same website to contact me directly. Thank you again, and good luck.